So Luke, I don't know when you asked this. You asked this a long time ago, so I'll talk to it now. Luke asks, how is the Raspberry Pi 4 different than an Arduino in terms of the GPIO pins? One, the Raspberry Pi 4, and I don't want to confuse people, but do I have one sitting around here? I do, but I'll have to reach for it. Raspberry Pi 4, stop sharing, is a mini computer. So it's actually a microprocessor. Its pin headers has 40 pins total. So it has a lot more pins. The downside is those pins are, for the most part, digital write and read only. So you have to use kind of external hardware to do like an analog read for a sensor. And that's why a lot of our more advanced sensors that use a different communication method called I2C or I2C are very popular with the Raspberry Pi crowd because they can talk I2C. And you can get things like GPS and barometric pressure and temperature and all that stuff. Can we discuss when you would use an Arduino versus a Raspberry Pi? Yes. So Raspberry Pi is a full-blown computer, and it is something that easily connects to the computer or to the internet. So if you're doing an IoT project or something that it's a full-blown operating system. So if I wanted to use a webcam and let's say host a website on a Raspberry Pi so that I can watch my fish tank while I'm on vacation, that is like a Raspberry Pi project. The Raspberry Pi, actually, you can build a website on the Raspberry Pi. It can host the website. You can use a little webcam on it to be able to capture pictures and then get that out to the rest of the internet. Arduino is very limited. Arduino is very good at numbers and translated numbers. So sensor data, controlling motors, things like that. Whereas the Raspberry Pi, like I said, it's a standard computer, and you can be having it do multiple things. So it can be like looking at a sensor and monitoring this thing over here while controlling another thing over here, and at the same time, turning these lights on and off. So it's really good at multitasking. Arduino is better for lower power consumption. So if I was going to put something on a solar panel out in my yard, I'd probably use an Arduino over a Raspberry Pi. When we get into topics like artificial intelligence and machine learning, Raspberry Pi would be a better choice for machine learning for the most part. There are some microcontrollers that you can do machine learning on as well. And there is a way to connect the Arduino to a Raspberry Pi. So the Raspberry Pi has USB ports, just like a computer does. You know what? Here, let me just do that. I'll grab one. So everybody. So this is a Raspberry Pi. Of course, I'm in the sun now. So this is a Raspberry Pi. If I compare it to a Redboard, size-wise, the Raspberry Pi is a little bit bigger, but it has USB ports. And I can actually have an Arduino read a bunch of sensors and send that data through the USB port, just like we're doing with our serial terminal. So the Raspberry Pi can use those numbers. I can also, the weird thing is, kind of inception thing, I can program an Arduino with a Raspberry Pi. So I can install Arduino on here, and it can program the Arduino. Does that make sense? So this is a tiny computer. This is like the guts of your cell phone, just without the fancy touch display. That's what it is. Any other questions? Getting a lot in the Q&A. Luke, Man, you're my man here. Expected closed parentheses at the end of input, or it might be curly brackets. So you need to make sure that your curly brackets are matched up, Daniel. So there's somewhere that you have an open curly bracket that you don't have a closed one. So double check on them. And when you're in Arduino, you can actually click on a curly bracket, and then it will go highlight its pair or its mate. So if you click on one, you can't find the other one that has a little box around it. You know that you found one. So Luke, no, you do have to use a USB cable for the most part. Okay, with that, I'm going to share my screen and my browser. Actually, hold on before I do that. Log out. Okay, now I can share my screen. So a couple of things. You have one of these. This is the PIR sensor. When you're looking at product pages on SparkFun, we always have a description and documents. So when you look under documents, we have what are called hookup guides. So those are the instructions. It's like the typed out version of what we just did. So the hookup guide has how to hook it up and some example code for you. So we're going to click on hookup guide. And it walks you through step by step what the motion sensor is, what you need to hook it up in terms of this specific circuit, an explanation of what it is, and then what the wire colors are. So this is a tricky sensor because a lot of people just assume that black is ground. In reality, if you look at and you read the instructions, red's power like it is normally, white is ground, and black is alarm. So that's when you're hooking this up, you got to make sure that you hook it up correctly. And then it gives you a hookup guide for an example. So just like I did with fritzing earlier, it's another fritzing drawing. I was talking to you about an Arduino Uno, how it's a tealish color. This is a fritzing drawing using the Arduino Uno. And red goes to the 5 volts, white goes to ground, and this goes to pin 2. And then we give you example code right here, how to use it. And again, it uses, it's as little code as we possibly can give you. And so it just basically says, hey, if this sensor is tripped, meaning there's somebody close by, turn on the LED and serial print motion detected. So you'd open up your serial monitor and you can see when there's motion. And then it gives you some resources for going further. So there's that one. I'm actually going to copy and paste this into the chat just so it's there. Ultrasonic sensor. So you guys have, there's 2 different versions. We just actually came out with a new one, but you guys have this one, which is the oldie and a goodie, which is a good thing right now. And I'm going to say example tutorial. And this is actually, we point you at an Instructables. So someone did a really good Instructable, we reward them. And here you go. There's the Instructable for how to use it. So there's the example. Another great guide, and you don't have all the parts in there, but another great guide that you have a lot of the parts for is the SparkFun Tinker Kit. So you're kind of have a modified version of this kit. And And this also has like all of the setup stuff for getting the breadboard installed and things like that. So if you were having trouble with drivers and all that fun stuff, this has everything you need. I'm also going to put this in the chat as well. This specifically has the motor controls. So this is why we didn't wire this live, because if you look at this, it has a lot of wires to control both motors. So this only shows one, but there's 2 motors here for wiring. So that's why we didn't do it today, because it would have just been really frustrating for us to do it live. But it walks you through step by step how to hook everything up, what this thing does, what it is, and then how to get it up and running. You also have the temperature sensor that's out of this kit. So someone asked about the little black half round thing. That's your temperature sensor, and it also has how to hook it up as well. So with that, Jan, do you want me to talk about the challenges that you're going to pose, or would you like to present them?
I can present those in just a minute, but did you want to share maybe some favorite really cool projects that you've seen done with Arduino?
Yes. Can everybody see this slide deck? Can I, Jane, before you quote, because I changed the tab, I'm not sure if it's...
I'm seeing a belt buckle.
Sweet. So a couple of favorite projects that I've both worked on and been around. So this is from early on in SparkFun history, because this is when we were still doing green PCBs instead of red. This is an MP3 player belt buckle. So this is the raw PCB designed MP3 player with an SD card. This is very geek chic, and a headphone jack. So I can plug in my headphones into my belt buckle and listen to tunes while walking down the street. This was actually in our old office, and you could see this across the street from this. Actually, there's windows behind me when I took this. This is a GPS-based clock. So if you don't know about GPS, GPS has actually highly, not only location, but you get very, very accurate time for your location. And so this was an attempt to say, hey, let's not only build a very accurate clock, but a very, very big one that everybody can see. So this was in our old office. It is about 8 feet wide, maybe a little bit wider, about 2 feet tall. And really, you couldn't have it on when people were in this office. We kind of used it as a nightlight for the building. If you ever thought about going to space, or at least the edge of space, it doesn't look like a lot, but this is a high altitude balloon built with SparkFun stuff. So jam a bunch of sensors and an Arduino and some radio equipment into a small foam cooler. And then you attach that to a balloon with a parachute, a weather balloon, that will go up to over 100,000 feet. Where you can actually see the curvature of the Earth. And then that balloon will pop, and your project will plummet towards back down to Earth. And at some point, parachute deploys and floats down, and then you actually have tracking radio equipment to go find it. I think our office record was 120,000 feet. I can't remember off the top of my head, but it was pretty high. High enough that you no longer see blue, but you see black in the sky. So this was pretty much an ongoing competition for a couple of years in the office of who could get the highest. When I moved here to Oregon, so our office is in Colorado, when I moved here to Oregon, I couldn't do it anymore, because if I let a balloon go up from where I live, it ends up blowing out over the Pacific Ocean. So these will go 30, 40, 50 miles if it gets caught in the jet stream and takes off. So you got to go track it down with a car, and it becomes an all-day event. Robots are obviously a thing. Battle bots being one of them. So this is a battle bot built out of some scrap plastic and, as you can see, lots and lots of hot glue, and then adding controllers. Big robots are a thing. So this is Maker Faire San Mateo. So this is the original Maker Faire. This is actually Arduino controlled. Controls all the valves for the propane. And a tiny robot that is essentially the hardware that you guys can make. So you have, I think you have pretty much everything that's on here except the wheels. So you have enough probably cardboard and can scrounge up some rubber bands to build wheels for yourself. So you can actually build something very similar to this with the hardware you have. Electroluminescence is a very popular thing. So building clothing and making yourself light up and blink. Halloween is a huge thing around SparkFun. This is it's supposed to be a GIF. It's not playing, but it's a flamethrower. So it actually spits fire out of the pumpkin's mouth. And one of the most recent projects that I got to be a part of, which was really fun. Anybody realize what this is or know what this is? Oh, come on, in the chat, you got to be able to name it. Or at least tell me where it is. Yep, it is on Mars. So this is the drone that was part of the Mars Endurance new rover. It has SparkFun parts in it. It has a Garmin, so a LiDAR unit that is the same. This one's in a housing, but it's the same LiDAR unit as this, so it's pointed down. So this is what tracks its distance off of the ground, as well as an IMU, or initial measurement unit, from us. And this was NASA exploring, can we use off-the-shelf hobbyist parts in some of our projects rather than spending millions and millions of dollars to develop it themselves? And so that was one of the things. They're like, we get a call from NASA and they're like, hey, what do you think of this Garmin unit? And we sent them a few and talked back and forth, and it ends up being that some SparkFun parts are in this. So it's been really, really fun to be a part of some really cool projects. And I didn't help with it necessarily. I helped with it in saying, yeah, and I maybe hooked it up and tried it out a little bit and said, this is the measurements I'm getting. But I didn't design anything or help out with anything at all. But was part of it, I guess you could say. I'm very proud of it. So that's the end of my inspiring projects. I have a couple other ones around my property that I can't walk you around, but I have a monitoring system in my garden, as well as an automated, I have the controller board. So this is a design I did, and I'll go back to my, stop sharing. So this is a board I designed, and this is a controller board for my automated chicken coop. So this is actually internet, it connects to Wi-Fi. It can control the door on the chicken coop. It has a scale that it can detect if there's an egg in the nest, so I don't have to go. I live in Oregon. Well, you guys live in Chicago. It's cold there, but it's rainy here. And then it has lights. So chickens, if they don't have enough light throughout the day, they won't lay eggs. So it basically controls the lighting inside the coop, and the temperature and humidity and all that stuff are monitored. So this is an extra controller board for that. That's a design of mine and a project, so that's been fun.